All right, good afternoon, everybody, and welcome to the September Northwest Gas Association webinar. My name is Connor Wrighton with the Northwest Gas Association, and many of you will remember that last month we were joined by Richard Meyer of the American Gas Association, who presented the first of two recent AGA electrification studies. We're fortunate to have Richard back again today to complete part two of that presentation. For those of you who did not log in for last month's presentation, you're encouraged to visit the NWGA YouTube page, where you can not only see a recording of that, but of any of our past webinars over the past several years. But we also ask that you finish this one first and then go back and watch that one again later. Again, Richard serves as the Director of Energy Analysis and Standards at the AGA, and we thank him for taking the helm 2 consecutive months. Today's webinar is going to focus on the role of natural gas in an increasingly electrified economy. But before we begin, we're going to review the basics for how this webinar system works. We have set aside time for questions. There's plenty of time for that, and we strongly encourage you to ask them as they occur to you. Please use the chat box in the GoToMeeting control panel. If you don't see it, there's a drop-down menu about just near the bottom. And you can type in your questions there, and I will introduce your questions as needed. For those of you who would like a PDF copy of the presentation, please send me an email at creiten@nwga.org, or just respond to the email that I sent out earlier, and I'll get you a copy before close of business today. This presentation is also being recorded and will be posted to the YouTube channel this afternoon. Please reach out if you'd like a link to that, or you can just simply put in NWGA on the YouTube search bar. Many of you know, the Northwest Gas Association hosts webinars like this once a month, and next month we're going to be hosting John Drayton, the recently retired LA Metro fleet manager who transitioned their entire 2,500 bus fleet from diesel to natural gas and then to renewable natural gas. We have scheduled out our webinar circuit throughout the beginning of 2019, and we encourage you to visit our events page at nwga.org to learn more and to get signed up in advance for them. Finally, I'd like to introduce the Northwest Gas Association for those of you who might not be familiar with us and what we do. We represent the 6 investor-owned gas utilities operating in the Pacific Northwest, along with the 3 large natural gas transmission lines. Our members are in Oregon, Washington, Idaho, and British Columbia. As always, visit our website at nwga.org for more information, or feel free to send me an email. With that, I will pass things over to Richard, and we will get started here in about 30 seconds.
All right, terrific. Connor, I know there's been a little bit of a background noise there. I don't know if hopefully you can hear me okay, though.
Okay, let me see if I can solve some of that.
But I will, so if you can hear me, I will ask also, can you see my slide deck? Make sure that's working well, and we'll jump in.
Yep, sound good, and we can see everything great.
Thank you for the introduction. Thank you all for being on the webinar today. For those of you that participated last month, I'm glad to have you back for part 2 of this kind of electrification webinar. For those of you that weren't on the webinar last week or I haven't had the chance to talk with or interact with, my name is Richard Meyer. Again, I'm a managing director here at the American Gas Association. I help direct our data and policy analysis shop. And one of the priorities that AGA membership has set out for us really over the last year and a half has involved this topic of electrification. And I'm going to talk I'm actually going to go back through very quickly a very, very short summary of just a few slides of what we covered last month, just so we're all on the same page here. And then I want to dive into the second piece of that I only got a chance to touch on in August. Connor described this webinar as the role of natural gas in an increasingly electrified economy. I would say that's only true if I'm not doing my job, or if we as a collective, as an industry group, aren't discussing the role and the potential roles that natural gas can play in a lower carbon future. And so this work is really, I've titled, it's not about electrification, it's about thoughtful pathways to U.S. emissions reductions, and specifically greenhouse gas emissions reductions. And the starting point for this work was electrification, and in particular what we call policy-driven residential. Very simply, that's the idea that you can use regulations or legislation to compel customers to switch from a fossil fuel-based direct use to electricity, and the idea being is cleaner over time. That is the way to drive towards deep decarbonization. This work has been done, as I said, it's been identified as a priority for me last year and a half, and we presented our initial findings in the electrification work to the AGA Board of Directors last February. And one of the things we got back, both from the Board of Directors as well as the steering committee, it was a group of members helping direct the electrification study. One of the feedback we got was, okay, this is great. We do need to understand the costs, the benefits, the implications of residential electrification. However, that's not enough. We also need to start developing work to understand what is the role of gas in helping meet our shared greenhouse gas emissions reduction goals. In other words, it's not enough to just say electrification policy is bad or not going to work or whatever. We need to offer an alternative vision and understand perhaps how, convey the message that natural gas is an affordable solution and can meaningfully contribute to greenhouse gas emissions reductions. So with that, I'm going to talk about some of that additional work that we've done and the way we're thinking about it. I will say that we started this work late in the process of the electrification study, so it is, I would say, less comprehensive. Not less comprehensive, but we are at the beginning stages of, I think, a number of years of work exploring these topical areas. So my good news for all of you is that this is not going to be as long a presentation as it was in August. I'm going to dive in now and just start with where we were last month talking about the electrification work. Again, recognizing out there in the policy space, many organizations, advocacy groups, national laboratories exploring this idea of greenhouse gas emissions reductions, deep decarbonization, and a recognition, almost an assumption really, that electrification of existing fossil fuel end uses in our buildings, in our transportation, that electrifying those end uses is the means towards deep decarbonization of the economy. So we see this idea of electrification almost assumed. And, excuse me, I'm going to move to slide 3. That prompted us to work with ICF International, a global consulting firm. They are based out of Fairfax, Virginia. And in July, we published the results of a study, Implications of Policy-Driven Residential Electrification. And we narrowed very specifically on a single, set of questions, but within the area of what happens, what are the implications when you electrify residential space and water heating, and policy to drive those changes. Just a quick overview. What were the key questions in the study? I'll just read these real quick. Will policy-driven residential electrification actually reduce emissions? How will it impact natural gas utility customers? What are those impacts going to be on the power sector and on electric transmission infrastructure requirements? In other words, if we're going to be electrifying a lot of peak winter loads, what's that going to mean for our electric infrastructure? What will be the overall costs So we look at cost to the consumer related to energy costs and the cost of purchasing equipment, as well as upstream costs. Again, if we're making electric infrastructure investments associated with peak electricity demand, what are those costs going to look like? And how do we then therefore look at the overall economic costs as a result of these policies? And then finally, how do those costs compare to other potential approaches to reduce greenhouse gas emissions? Again, if these policies may be pursued for a number of reasons, but the primary one generally has been to drive greenhouse gas emissions reductions. So what are the costs associated with these policies in terms of the emissions reductions achieved? A little wordy, I apologize, but some of the key findings from the study. Simply put, we found that policy-driven residential electrification would be burdensome to consumers, and it would increase the average residential household costs in general and on average. We see that widespread residential electrification would lead to increases in peak electricity demand. Again, we use a lot of energy to meet our peak winter heating requirements, to heat our homes, to heat our businesses on those coldest days of the year. And if we electrify those end uses, the result could be a need in significant new investments in our electric grid infrastructure, including new generation capacity, transmission, and distribution as well. Overall costs, we're talking about $500 million to $1.2 trillion when you roll all of those costs up again, cost to consumers and the upstream infrastructure costs. I might add, those costs that we modeled should be seen as somewhat conservative, since there were costs that we did not address in this work. Of course, these depend on local conditions. The conditions in the Pacific Northwest will look different than, say, in Arizona, and again, different than if you're in the Southeast or, up in New England. Regional aspects of this were important to understand and suss out, and of course, we covered a little bit about that last month. Finally, and important to today's presentation, is that policy-driven residential electrification would be a very costly approach to emissions reduction and probably much more expensive compared to other reduction options. This next slide from the report illustrates that now. And we see the kind of range in costs of emissions reductions, so the units being dollars per CO2 reduced. If you look to the right-hand side, the top right-hand side, those were our average U.S. costs associated with emissions reductions. In other words, depending on the generation scenario and how we modeled it, we're looking anywhere from $600 to $800 per metric ton of CO2 reduced. Anyone familiar with emissions reduction strategies and the costs associated with those will probably quickly recognize that that's very expensive compared to some other options. And, we can see that other options, or how we quantify that, might be, what a certain state or, the EU, for example, prices emissions at in terms of dollars per ton. Also, the social cost of carbon, generally estimates the median values for that much lower. And so on and so forth. Even atmospheric CO2 removal, directly pulling CO2 out of the atmosphere, we see upper bound costs based on the current literature of $232 per metric ton, still well below the cost per ton we're seeing as a result of this policy-driven residential electrification. So now, perhaps this leads us to a place where we can step back and offer a different vision. One where natural gas can meaningfully contribute to CO2 reductions and can help contribute to our shared goals of meeting greenhouse gas emissions reductions. So we call this a thoughtful pathway, or a more thoughtful pathway. And I just want to emphasize the very simple messages that I'm leading with when I talk to groups that are in particular interested in, first and foremost, driving emissions reductions, and those folks often skeptical about the future role of natural gas in meeting those emissions reductions. And I remind them that first and foremost, natural gas is very affordable and has already contributed to greenhouse gas emissions reductions. We have a great history of emissions reductions. We're going to go through some of that data in a second, and it will continue to do so. It won't continue to do so without additional work, and it's incumbent on the industry to step up and make those necessary investments and commitments to drive emissions reductions, but it can do so. And in particular, natural gas utilities are committed to reducing the environmental footprint of their customers' energy use, and in particular, driving down the greenhouse gas emissions from their customers' energy use. I'm going to go through a few slides just to set the stage, the historical picture of the history of natural gas utilities doing just that. First, look at where we are today and where we were 40 years ago. Since 1970, we have added in this country collectively about 30 million new households to natural gas. So this is based on EIA data and the number of customers. So we've added 30 million more gas meters, and effectively we haven't increased natural gas use in that sector at all. Flat demand, increasing number of customers. So that is in part due to declining use per customer. Residential customers use today about half the amount of natural gas they did 40 years ago. So as we're increasing the number of customers, the amount of gas the customers are using has been declining. This is a result of energy efficiency programs, consumer conservation, just general improvement in trends in terms of better appliances, tighter building envelopes. It's a great story, and it's one that I just think is not properly recognized outside of this industry, and it's one we need to continue to communicate. But because natural gas use per customer is going down, that means CO2 emissions per residential customer are going down. And again, reminding folks that the average residential consumer of natural gas releases half the amount of CO2 because they use half the amount of natural gas as they did 40 something years ago. So we have a continued success and a demonstrated track record in reducing customer usage of customer CO2 emissions from natural gas use. So that leads me to, I think, how we're characterizing as three kind of pillars of action, or three ways that we need to think about how gas can contribute to meaningful reductions in CO2 emissions. And simply put, the first is the continued commitment to energy efficiency. Natural gas utilities, we're spending billions of dollars, $1.5 billion budgeted in 2017. I'm actually waiting for my colleague to give me some of the actual numbers from 2017. My team is collecting that now. But let's say, $1.3 to $1.5 billion per year spent on energy efficiency programs targeted to residential, commercial, industrial customers. These programs, as you all know, within your companies or working with companies that facilitate those programs for you, these dollars are committed and achieve efficiency through many forms. It could be appliance rebates to whole home retrofits, and there are many variations on the theme. This commitment to efficiency, I think, has been demonstrated and has continued to be demonstrated over the growth in total programming dollars that have been committed over the past decade. And it is incumbent on the industry to continue to push energy efficiency programs and solutions for natural gas utility customers. The second pillar in this, let's call it a natural gas pathway, a pathway towards achieving emissions reductions. It includes advancing innovative natural gas technologies. This brings me to the work that we did in parallel to the ICF AGA study on electrification. And coming out of that the meeting with AGA's board of directors in February, we sought some help from a group called Innovation Partners. and they're a firm with extensive knowledge of natural gas technology development. And we asked them to help us get our arms around, what is the role and potential for gas technologies to reduce emissions. I'm going to go through some of that work in just a second, but this is a slide from their presentation. And it just very simply demonstrates that advanced natural gas technologies can meaningfully reduce customer level CO2 emissions. And I'll revisit this point again in a little bit, but they see 25 to 40% greenhouse gas reduction potential on a customer or household basis. And I'll say this work was primarily focused on the residential and small commercial sectors, since the electrification study that we engaged in was only for the residential sector. We want to just start with those sectors and natural gas solutions there. That, of course, does not mean that there are not other potential opportunities outside these areas. And quite frankly, that's an area ripe for additional work from us or others even. So I'll come back to this, but the first pillar being advanced energy efficiency. The second, we need to continue to research, develop, and deploy advanced and next generation natural gas technologies. And then finally, the third pillar, if you will, of our pathways involves the advancement of renewable sources of natural gas supply, such as renewable natural gas and power to gas technologies. I'm not going to focus a lot on renewable natural gas today. Perhaps there will be an opportunity to come back and talk with you all in the future about this area. But I will say it is one that I'm seeing increasing interest from a number of AGA members and even from outside the membership, and it's an area of focus that I've been putting a lot more time in. But let me back up. Simply put, renewable natural gas, this is biogas or biomethane produced from existing waste streams and biomass sources. So we're talking animal waste, landfill, crop residue, food waste, dairy farms, so on and so forth. We capture that biomethane and upgrade it so that it becomes pipeline quality and use it in end-use applications. Now we're talking about a renewable natural gas solution that can help decarbonize the natural gas stream. Renewable gas production has grown considerably over the last several years. Yes, due primarily to federal and state policies that recognize and value the environmental benefits that renewable natural gas provides. Actually, according to the Coalition of Renewable Natural Gas, which is the industry association for the development of RNG, there are at least, I believe, 70 RNG facilities in North America that are currently injecting renewable natural gas into the gas pipeline system, and they are projecting that this number to double over the next several years. So there's potential here for continued growth and decarbonization of the gas pipeline. Let me mention power to gas very quickly. This is probably a next generation technology, but the idea here is to take renewable sources of electricity, create a hydrogen gas using an electrolysis process, and then taking it another step, using a methanation process and generating a kind of synthetic methane or a methane created from a purely renewable source of energy. So this isn't biologically generated, but this would be from, say, renewable sources. This is an interesting potential technology as it could serve as a storage medium for excess renewable electricity on the grid. Suffice to say, but with renewable natural gas and power to gas, this third pillar of our natural gas pathways is promising and promises even deeper greenhouse gas emissions reductions from natural gas technologies. I'm going to dive into the Innovation Partners work for the next few slides and then come back around and try to wrap this all up. Connor, have there been any questions that are worth addressing at this moment, or should I just plow ahead?
Let's keep moving forward. Just remind folks, please type your questions to the chat box.
I think I heard you say that they could enter the questions in the chat. So if you have any questions on anything I've presented, please let me know. Let me say this, that the next few slides are directly out of the Innovation Partners work. Again, this is that kind of parallel study we commissioned while we were working on the ICF electrification study. And we asked them to develop and identify and assess emerging natural gas technologies that could contribute materially to greenhouse gas emissions reductions. Many of these slides are very busy because there was a lot of work that went into it. They evaluated more than 100 different natural gas technologies and tried to convey the benefits or potential emissions reductions from these technologies in a number of different ways. I'm only going to show a few of those slides. The entire presentation and work is available on our website, and I'd be happy to link you to that or get that to Connor and pass it along to you. I probably will go through these a little faster than you're able to read everything. I'm happy to go back through during a Q&A to revisit any of these, or again, you can revisit it on your own time, which actually may be more useful given the kind of all the details on each of these slides. But as an example of those details, you can see here that of the various types of technologies within the residential and commercial space that Innovation Partners evaluated for us. So they had different end use pathways, which these I guess they're hexagons. Those represent different end use pathways, and within those, they assemble different candidate technologies. So for heating and cooling, looking at candidate technologies or pathways for condensing furnaces, natural gas heat pumps, solar thermal and heat recovery. So different technological pathways that would include natural gas to meet that end use need within that sector. So this just demonstrates effectively where they were looking, and in particular where they weren't looking. So we're looking at water heating, cogeneration, laundry, cooking, heating and cooling. We ignored transportation. Not so much ignored it, but we did deem it outside of the scope. Our thinking here was that we are looking for alternative pathways to electrification of space and water heat in the residential and other sectors. So we wanted to set transportation aside for that purpose. Innovation Partners evaluated over 100 different technologies, and they identified within various end use areas high priority technologies, and they prioritized these along a number of different variables, including potential future cost, emissions reduction potential, their professional view of how far away these technologies might be in terms of their development cycle, or how close they might be to commercialization. I won't go through here. I mean, you can see some on the top left, some potential in the space heating realm. So low cost residential gas absorption heat pump combinations, advanced condensing furnaces, transport membrane humidifiers. I'm not a technologist myself, so I wouldn't be able to go into the details of what all of these, what every single one of these technologies means. But nevertheless, it was our AGA and our first attempt at again identifying and assessing emerging gas technologies that could contribute meaningfully to emissions reductions, and looking at different customer end uses and potential solutions they might explore that would offer or they would have as an option to them to reduce their emissions. Pulling this back up and recognizing I highlighted this before, but one of the principal findings from Innovation Partners was that currently available efficient gas technologies can more affordably achieve targeted greenhouse gas reduction goals through 2030. They see on a customer basis, based on their technology review, a 25 to 40% emissions reduction in terms of greenhouse gas emissions. This was, to us, an important finding because it is about what the overall emissions reductions were projected to be from electrification. So again, let me step back and say we did a national study on policy-driven residential electrification. And if you looked at just the residential sector emissions reductions that were achieved across the board, across the entire U.S., it ended up being commensurate, about 30% or so. I'd have to go back and look at the exact number. That's about what we found with this evaluation. So in other words, natural gas technologies through, say, the year 2030 could offer the same amount of emissions reductions as these, what we found to be high cost and potentially very burdensome residential electrification policies. Furthermore, the gas infrastructure is already in place, so there would be no need to build out more expensive all-electric pathways to achieve those emissions reductions in that electrification pathway. So this, for us, was the first step towards raising a flag and saying, wait, gas can be part of the solution. Here, we're evaluating these 100 technologies, and consumers might want these technologies, and it might be lower cost in terms of our policy objectives in meeting our emissions goals. To illustrate some of those findings, as we worked through with innovation partners, one of the suggestions was to put together some vignettes. In other words, let's create an actual scenario an illustrative scenario with illustrative but potentially actual customers with, based on their needs and their ability to pay for energy, so on and so forth. And let's show an example of how these advanced natural gas technologies compare with these potentially all electric pathways. The bullets here on this slide are all of the vignettes that are available in the full work. The starred, the asterisks indicate the two I'm about to show you. So there's a zero net energy home in Chicago and a low income family renting in Hartford, Connecticut. I have a third one I'll show you in just a minute, but it ties the RNG idea in there as well. But nevertheless, all of these vignettes are available in the full presentation from Innovation Partners. So if there's something here that I haven't presented that you'd like to go through today or look for, I just wanted to flag those for you. Here's what the vignettes look like on this next slide. I'm not going to go through all the details here, but this is, again, an illustration, both with what I'll say, illustrative quantifications of what the costs and emissions reductions might be between a all electric or in this case, a zero net energy home that includes natural gas. Anyway, to quantify the different potential pathways here, and using, in this case, an actual couple. These people actually exist, and they were building home near Chicago, Illinois, and they had these preferences when they were building their home. So you can see here written down, Nick Rumis and Shihai Kang. They were building a zero net energy home in Chicago, Illinois. Sustainability was very important to them, but they wanted it to be affordable as well. Natural gas plays an important part in both of these. And so here we can see that the two different options that they could have considered. And so you've got the single family residential home. It's 2,200 square feet, what their median income was, what their energy sources available to them were, which includes not only utility scale utility gas, but solar rooftop PV and a battery system on site. And then, of course, the technologies they included in their home. Suffice to say, the zero net energy home, which includes, in this case, natural gas, and the all-electric home saw similar emissions reductions. And the cost of those emissions reductions, while significant in terms of dollars per ton, were equivalent to each other. So here's a home in Chicago, a sustainable zero net energy home, so certainly a stretch goal in terms of what consumers might be looking for, but one where natural gas can still contribute similarly to what an all-electric option would have been. We're going to move to the next one. Again, this is an illustration of of a single parent, in fact, renting in Connecticut. So a smaller home than in the prior example. In this case, the landlord's making the decisions about the appliances on site, and they will, as the landlords tend to do, are looking at first costs as a primary driver for their decisions. So in this case, first cost was very important to the landlord, choosing least expensive options, and they chose natural gas being one of those least cost options. So again, the technologies in this home: a natural gas furnace, the water heating with a high efficiency gas boiler, so on and so forth. Again, so this is a little bit different of a case. This is a lower income household, a renter, LIHEAP eligible. So affordability is really important. And here, natural gas can, again, meaningfully contribute to emissions reductions, but while keeping the energy cost to this affordable. As I said, I'm going to move through these. I know there's a lot of details on these slides, and I encourage you to revisit them after this presentation today. One of the other findings from Innovation Partners was that with continued investment and advancement in natural gas technologies, and with the inclusion of renewable natural gas, that 60 to 80% reductions in customer greenhouse gas emissions are possible. You know, at these levels, we're talking about emissions reductions that are sufficient to meet COP22 goals, is the Paris Climate Agreement from a couple years ago. And there were 3 vignettes in this case, but I will show the large single-family home in Oregon. And in this case, this is in 20. So we are now in the future. And Liliana and Jay have a home outside of Portland that is a showplace of new technology. And they're a few years ahead of their neighbors, and they want to be. They are a couple in their 50s with no kids, most concerned about demonstrating sustainability commitment while enjoying the full potential of technology. So these are folks that have some money to spend and on their home and on their energy, and they want to take it to. So now, again, as an illustration, what does the advanced gas option look like versus an all-electric option? And in this case, we see CO2 emissions reduction potential much higher than that of all-electric. This is because renewable natural gas has been integrated, and depending on the source of renewable natural gas, we could see potentially zero or negative total emissions on a life cycle basis, because perhaps methane is captured that would have otherwise been released. I hope that makes sense. I'm going through that fairly quickly, but in other words, RNG offers greater than 100% emissions reductions in this example. The cost of those emissions reductions in terms of dollars per metric ton, also less than the all-electric option. Again, there's probably a lot of ways to challenge or question these vignettes. They are right now just illustrative, but we hoped as we asked Innovation Partners to develop these, that they would help put it into a consumer-friendly context. So as opposed to just a spreadsheet with 100 different gas technologies telling us how great, how much emissions reductions can be achieved, it was rather putting into those gas technologies into a context that recognizes what consumers want in terms of affordability, sustainability, or other potential desires. So just to summarize, again, Innovation Partners evaluated 100 plus innovative natural gas technologies in the residential commercial market. They found that near-term advanced gas technologies could achieve 25 to 40% greenhouse gas emissions reductions on a customer basis, and that in the future, with the integration of more advanced technologies and renewable natural gas, that 80+%, 60, 80, or even higher percentage of greenhouse gas emissions reductions would be possible. I'm coming to the end of what I have here, so I would just reiterate those really three pillars, and this is my words, but priority areas for potential action from AGA or maybe the industry. And first, it is important to continue to increase access to high efficiency natural gas appliances, and reminding everyone that utilities are working with policymakers to enhance energy efficiency program offerings and to ensure that all customers have access to high efficiency natural gas appliances so that we can reduce emissions and reduce customer costs. Second, we need to continue to advance research, development, and deployment of next generation natural gas technologies. AGA, we work with the Department of Energy to make sure that R&D programs have appropriations funding, talking with policymakers, regulators, and other stakeholders, reminding them that the gas industry, working with groups, say like the Gas Technology Institute, are investing dollars to continue to advance natural gas technologies. But that more probably needs to be done, and a continued industry commitment towards to advancing natural gas technologies will be necessary if we're going to allow natural gas the ability to continue to participate and achieve emissions reductions and quite frankly, be a solution to customers, an affordable, low emissions solution for customers. Then finally, as I mentioned, we need, as an industry, to continue to explore ways to develop renewable natural gas. And there are a number of areas where I know individual utilities are working on this. In particular, out west, I've seen evaluations of renewable natural gas potential in California, and I think just this week, maybe even the last couple of days, I saw one, a renewable natural gas potential evaluation for Oregon. These things are happening, and I step back in my role at the American Gas Association, ask what is the role of a national trade association? Do we need to update our understanding of renewable natural gas potential in the U.S., and what other steps can we take to help advance the industry opportunities within the renewable natural gas space? With that, I look forward to questions or comments, and feel free to reach out to me afterwards anytime if you have any additional points.
Excellent. Thank you, Richard. Again, I don't have any questions at the moment, so I will encourage folks to go to the chat box and leave a couple of questions there. I know there was a lot of information in there. Again, we will be putting this in PDF format to those who ask for it, so you can go back and review some of those slides. But again, it's a great time for questions, and while we wait for those, I just want to once again express our gratitude to Richard for taking the time to do this.
Well, thank you very much. I appreciate the opportunity. And again, I look forward to any questions you might have, as well as any comments. I will admit to this group that this is the first time I've done presentation quite in depth. Oftentimes when we're out on the road or talking with other folks about the electrification work, that's the primary area we focus on. And so I really appreciated the opportunity to kind of dive into the secondary parallel piece of work that we produced alongside the ICF electrification study.
Well, Richard, we've got one question. I think you may have addressed it a little bit in the sense that you mentioned that this is the first time you've presented it, but have you had any initial feedback from groups about decarbonization?
Yeah, I think the initial reaction to some groups from this work has been, well, you know, you've evaluated all the costs on the electric side. What are the costs on the natural gas side? And to that, I would say that's a very valid point. And there is more work to be done. I didn't really go into all of the background on the innovation partners work in the project scope, but this gas technology pathway was only the first step. And we have other potential areas that we could go down, and that includes how penetration of natural gas end use technologies could change costs and emissions at the system and national levels, and compare the costs of these gas pathways with other potential emissions reduction pathways. So recognizing that we started this gas pathways work probably towards the end of this electrification work, the first step, of course, was we needed to understand the implications of electrification policies being proposed. But we are just taking initial steps now in offering these gas pathways and the potential and our understanding there. So, in other words, there's more work to be done.
We've got another question here about the cost-benefit ratio of developing renewable natural gas. Do you have any way of sort of conveying what that cost-benefit ratio is?
I would suspect some folks on the phone might actually have a better answer to me. I don't have an answer to that. I will say that it depends, and it depends where you are. It depends how the renewable natural gas is used, and it depends on the types of incentives in place. In some places like California, both federal and state incentives are available for use of renewable natural gas in, say, the transportation sector. There are not similar federal or state incentives to, say, use renewable natural gas in a home heating application. So the cost benefit's going to differ depending on, again, where you are, the types of renewable natural gas sources you're tapping into, as well as the where it's being used. So that's my kind of way to get out of that, answering that question directly. But I think those elements are all relevant.
Sure. So the next question here is, what are the next steps with innovation partners? Is there a second phase to push forward some of those specific technologies?
It's certainly being considered. And right now, from my chair and talking with my colleagues, we are still out there communicating the findings of both the ICF AGA work, as well as the innovation partners and AGA work. And I think that there's a number of potential ways we could expand on this, whether it's with innovation partners or with another group. But suffice to say, we have considered additional proposals, and we are evaluating where we need to prioritize additional investment and additional work in this area. So that is to say, we're thinking about it and we're working on it. And we are intending to take, again, whether it's with innovation or another group.
Terrific. Well, unless somebody comes in with a question while I'm wrapping up here, I think that probably brings us to the end of our webinar. Thanks again, Richard. We'll look forward to continuing to work together on things like this, and look forward to the next steps.
And I'll tell you what, for everyone on the phone, I will send the link to Connor to the full innovation work and, of course, the ICF study. That's all available on the AGA website. So if you want to dive in deeper on either of these studies, that will be made available to you. And thank you all for your time and attention today. I appreciate it.
Great. Well, look forward to seeing everybody back on the webinar on October 18th. Make sure to go to nwga.org to sign up for that, and we'll look forward to it.
Terrific. Thank you.